So exam one review, I'll work through the first 4 questions, and then from there, we'll kind of open it up to what questions you want to look at. I'll just do the first 4 questions in order because there's a question for number 4. And to answer number 4, we kind of have to do all the questions before them. And hopefully you saw, I shared it in Discord, but I made a video kind of breaking down all the equations from this module. And hopefully that helps give you an idea of how to use, each equation or when to use each equation. But this first one, if you have a data table like this, that is nothing but concentrations, right? This is a case where we have to find the rate law. And to find the rate law, I kind of gave you that equation where we're going to kind of look at, concentration 1 over concentration 2, all raised to the power of n equals the rate over the rate for one reaction over the rate of the other reaction, where this power of n equals the reaction order with respect to that reagent in the reaction. So for iodine, right, we're going to take a look at the data table. For iodine, we notice we need to find 2 experiments where the concentration varies for iodine and is held constant for the other species in the reaction. So if we look at experiment 2 and 3, we see that the concentration of iodine changes, whereas the other concentration stays the same. So we need to compare those 2 concentrations and the 2 corresponding rates. So for iodine, I would say, okay, 0.150 divided by 0.075. And I always like to divide the higher concentration by the smaller concentration so that we're staying with whole numbers. So I'm going to divide that corresponding rate. So 2.6 times 10 to the 4 over 1.29 times 10 to the minus 4 minus 4. Let me just focus on the practice exam first. So we divide those 2 and we get 2 to the n equals 2. So this tells me this is a first order reaction because 2 raised to what power equals 2? 2 raised to power of 1 is 2. So with respect to iodine, this reaction is first order. Now we need to do that for the other species in the reaction. And for this one, we're going to look at experiments 1 and 2, because now iodine stays constant and this concentration is doubled. So again, I'm going to put the higher concentration on top. So 0.9 divided by 0.45 raised to the power of n equals 5.16 over 1.29 times 10 to the minus 4. Now I divide those 2 and I get 2 to the n equals 4. So what this means is I doubled my concentration, but my rate of the reaction quadrupled. So 2 raised to what power equals 4, right? 2 squared equals 4. So this means our reaction with respect to the other species in the reaction is second order. So now we can have our rate law. Our rate law is going to say rate equals the rate constant times the concentration of iodine to the first times the concentration squared. First order with respect to iodine, and then second order with respect to the sulfate containing compound. So now we kind of answered question 1, we answered question 2, hopefully. All right, question 2, yeah, we found that it was second order, right? So, sorry about that. Found that it was second order. Overall order of the reaction, well, we found that the rate law for this reaction was rate equals rate constant times concentration of iodine to the first, S2O8 to the second. Overall reaction order is the sum of each individual orders So 2 plus 1, right? The overall reaction order was 3. That shouldn't have been too hard. Now for question 4, yeah, question 4 tripped up a few people, right? All that question 4 is asking, what is the magnitude of the rate constant for this reaction? So to answer question 4, we just want to go to the rate law and then pick one experiment. So I'm going to pick experiment 1. So in experiment 1, for example, I have a rate of 5.16 times 10 to the minus 4 molar per second. That equals my rate constant. I don't know my rate constant, times the concentration of iodine in experiment 1, so 0.075 molar, times the concentration, right, 0.9 molar squared. So that's all that we have to do for question 4 to find the magnitude of the rate constant, right? I'm going to multiply the two concentrations, divide it across, and solve for our rate constant. So I'm going to square 0.9, multiply that by 0.075, divide that across, and I get 5.16 times 10 to the minus 4 molar per second equals rate constant times 6.075 times 10 to the minus 2. Yeah, that's going to be molarity cubed. So divide both sides. All right, 6.075 times 10 to the minus 2. All right, one of those cancels out, one of those cancels out, and we can solve for rate constant. And I get something like 8.49 times 10 to the minus 3, right? So 8.49 e to the minus 3. It's going to be inverse molar, or molar to the negative 2, seconds to the negative 1 for units. Not that it asked units, but that gives us choice A, right, for question 4. So any questions on 1 through 4?